Let me see the message in the chat by Fernando. It's here. No, it's here. Okay. Let's see. Error unexpected bracket. One second, I try to understand what is this. So, okay. Expected bracket, okay. Okay, let me reply in the chat. Okay. Fernando, can you hear me? I think you should. Okay, very good. So I'm looking at the chat. Let me share the screen and your message. So let me. Now here, there is a problem in the syntax of the command. If you look at the mouse, my hand, here there is a problem in the syntax. And therefore, the error message is that when you close the cycle with the curly bracket, there is a problem. So what I see here is, first of all, this 0.1 that should go out of the round parenthesis, but I think this is not the problem. The problem is, in my opinion, the fact that I don't understand why here there are these plus signs, which shouldn't be there. 1 plus sign is fine, but 3, no, there is something that it's odd, okay? So I think this is the problem actually. And therefore, try to type the instruction as I did. You can get the video and get it back. And if you type the instruction like I did, it must work, okay? Here, as I said, the problem is this plus. I don't understand how you got them. So please try, and not necessarily now, and then I think for sure the error will go away, okay? Now, I am now on another PC. Let me see if R is here. Otherwise, I think not. So give me 1 second to install it. Firefox. I cannot install RStudio here, unfortunately, and therefore, unless let me try to connect my PC to the screen, because probably, okay, let's do, first of all, I install it. Okay, so let me install our project. Okay. 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 Download art for Windows base. Okay, that's it. Give me 1 second. And then I would like to see if RStudio can be installed here. I don't think so. Okay, I get R, and now let me try to see if I can install RStudio. I don't think so. I don't think I am allowed to do that, but let's see. Who knows? Maybe that something changed. Okay, R is installed. Finish. Perfect. And let me see RStudio. No. Okay. I cannot install RStudio, so be patient. I now start R alone. R alone, I can only visualize the console, but if I make a plot, then another window is open. So it's not a big difference. You can follow me, okay? Yeah, open RStudio, yes. Open RStudio. I think it's better if you continue with RStudio. It doesn't change anything from my side because I am also used to, I mean, RStudio is just putting together several windows, but it's not really. Okay, let me just summarize a little bit what we did. Basically, what we did is to run a for cycle. So let me just try to repeat a for cycle for E in 1 to 10, okay? And then I put a curly bracket here, and sorry, I don't get the curly bracket, so let me check, because this is a different keyboard. So let me do this, no, and okay, so let me see. Let me just try. I think it is something here, no. Okay, good, Alt-Shift. Okay, what I did is Alt-Shift square bracket, and I just made a couple of attempts by chance. Okay, and let's write here something like print on the screen, world is nice. Okay, and it will be printed, and let me see, fill equal true, it will be printed 10 times, okay, and then curly bracket, okay, and this is the result. Now, this is typed over the console, but actually what I wrote is a code that was directly typed over the console. And the same thing for the for cycle that I did earlier. Now, you understand that typing on the console has the problem that, I mean, if I want to repeat it, I have to type it again. And therefore, it may be more useful to write a real code, so to write over a file, and over a file, I can write the for cycle, and then I can upload the file into R. This is what we do also with other softwares like MATLAB, etc. So how to do that? So write over a file means that we open a text editor, and the text editor, I take Notepad, it's blocco note in Italian, let me see, blocco note. This is a very simple text editor that runs under Windows, and I can write here my for cycle for E in 1 to 10, okay, and then the bracket. Really, the bracket is not strictly needed because it's only one instruction, but just to make things more complicated, let's do that. And the world is nice. Okay, and then fill equal true. And then the other bracket, sorry, Alt-Shift here. Okay, let's save it. To save it, I make file and save, okay, and it will ask me the name, and usually it is saved in desktop, and I prefer to save it in desktop, not in OneDrive as I see here. So I prefer to go over the desktop, 1 second, this PC, and then And then I don't understand why it doesn't show me the desktop. 1 second. This PC, it's on. Okay, I can save it in Documenti. Let me see. Okay, I can save it in Documenti. And then the file name. So let me just call it my for cycle. And let's give an extension .r in order to recognize it. Okay. So now this is in Documenti. Okay. And perfect. Now, how to upload this into R? Okay, the command here is source, and then I have to give the file name. The problem is, let me check if it is here. I don't think, yeah, it is already in Documenti. So let's just show you what I did once again. Besides the name of the file, you have to give the path. And in Windows, to give the path is not so easy because you cannot give the path into R by opening a window. And if it was in the desktop, I should know the path of the desktop. It's not so easy. But if it is placed in documents, R goes by default to look into the directory documents. I got it just by chance. How could I verify it? Because after the file name, after the commas, I tried to include the first 2 letters of the file name, and then I pushed tab. And then it's there. And see what happens when I type enter. Okay. It has repeated, it has applied the full cycle. So what I did is to write a code over a file and upload it into R. Nice, okay? And then if I want to load it again, source my file, okay? And then I can modify it. So if I want to write, the word is very nice, I go over Notepad, I save it, and then I go into R, and I upload it. This is something that makes, when you have something complicated to do, of course, if I have to compute 2 plus 2, it's easier to go over the keyboard and do it. But if you have to write a long sequence of instructions, it's much better if you write it over a file, and then you upload it into R, because it's faster. When you want to change it again, you don't have to recall back the previous instructions with arrow up. It's much easier. Perfect. Another thing that I want to tell you, we have learned that there are, yeah, please, the question.
When the code running and reading the source, when you continuously write the word business, continuously, not separately in the in the lines, separate lines.
You mean in your PC?
Yeah.
Yeah, but I think the problem is just that you didn't use fill equal true. Okay? Okay, good. Now, we have learned that there are functions into R. I cleared the console. So, for instance, we have learned that log10 of 100 is to be computed in this way. This is a function. These are called into R functions, meaning that they are instructions that are performing a numerical computation, which you don't have to specify in detail. It's just sufficient that you say log10. And the function understands that you want to compute the logarithm on base 10, and you give as an argument 100, and it is computed. And the argument of the function must be given between round parentheses. So just notice that. So if I want to take an element from a vector, I have to use the squared bracket, the square bracket. But here I have to use the round brackets to give the arguments. Good. Now, what if I want to write my own function? This is possible. And it is possible, and because, for instance, I may want, and now let me go to the code, to the file of the code, I delete it. Maybe that I want to compute this operation. And the operation is, let's suppose that I have two variables, A and B, and I want to compute C equal A plus log 10 of B. So I want, based on two arguments, A and B, to compute this function. Okay? How can I upload it into R? First of all, I have to tell R that this is a function. Okay? And I have to give it a name. So my function is the name, is equal to what? Function. Function is a function to define a function, okay? So function, and I have to give the argument A and B. So I have to tell R, look, I want to create a function that is called my function that takes two arguments called A and B, and the result of the function is C, okay? Now, do you want to give a default? Okay, let's give a default to B. B equal 100. Maybe that it's nice to give a default, because otherwise, if there is no default, we will see what happens. And then let's open here a curly bracket for the same reason. I closed the curly bracket here. For the same reason, I mean that I have a series of instructions, because it's not only this instruction. What is the second instruction? The second instruction is return C, which means C is to be printed over the screen. This is my function, and I save it. Okay? Return C tells R to print C over the screen. Okay? And to give it back to you, because otherwise it makes the computation and it doesn't give back to you the result. Okay? Now, let's upload it into R. Look, I didn't change the file name. It's still named my for cycle, okay? Again, source my for cycle r.txt. One thing, you see that Notepad used two extensions, because Notepad, by default, gives the extension txt. Actually, this is something not advisable, okay? Use files with only one extension. I didn't notice that. And it's better if you remove it, and it can be done with File Manager of Windows, okay? But I mean, for our purposes today, it doesn't matter. Now, there are no errors, so it is uploaded. So let's try to compute my function. Let's try to complete it with the tab. You see that it is completed. And then to my function to for y, because look at the function. The default for B is 100, log 10 of B is 2, so 2 plus 2 is 4, okay? I could have written something like 2 and 1000. So I override the default, and then the logarithm base 10 of 1000 is 3, and the result is that one. I could also write something like A function to, and then if you see A is 5. It is not a problem if you define with the same name A the variable in the root of R and another variable in the domain of the function. They operate on different levels, okay? So there is no superimposition, and the variables that you use in the function are not returned into the root unless you tell it with return to send it back. So this is a perfect example of coding, and if you here make things more complicated, it is perfect. It is something that can be done. And let's make an experiment, okay? And the experiment is try something that you already know. Let's suppose that we have to estimate the Gamble distribution, with the Gamble distribution, an extreme value starting from a series of observations, okay? First of all, let me generate the series of observations, or let's say that we can also create it. So let's make the series of observations in this way. My observations equal. Let's put manually a vector. If you want to create a vector manually, you have to use the function C, and then the elements 2, 10, 4, 8, 25, 19, 1. I'm just going by chance, okay? 9, 22. This is my vector, my obs. Okay, good. Gamble distribution. I want to write a code that estimates, starting from these numbers, estimates a Gamble distribution and gives to me the value estimated for probability of not exceedance of, let's say, 1%. Okay? Gamble distribution. You can write the Gamble distribution in different ways, and so I'm not sure what is the way you used to estimate it. So let's see. I tell you how I write the Gamble distribution for the cumulative probability. And just 1 second. Okay, forgot to switch it off. I write it in this way: Ex equal to E at the power of minus E at the power of minus alpha x minus U. You may have seen it in a different way. It depends if you how you define alpha. So there are some people who write it in this way: x minus u divided by beta, and then alpha disappears, minus. Okay. I prefer the way it was written before. But if you check what you did with my colleague Serena Chandler, it's very similar to this one. Okay? The nice feature of the Gamble distribution, again, this is probability of not exceedance. Okay? The nice thing is that it can be easily inverted. So you can write here logarithm of bx. It's equal to minus E minus alpha x by u, minus u, sorry, okay, I think you can see remotely, and then let me change the sign. So logarithm minus logarithm bx is equal to minus alpha x minus u, and then we can do this, plus minus, okay? And then I can write it in this way. Sorry, alpha minus logarithm minus logarithm bx is equal to x minus u, okay, and then allow me to bring u left-hand side, okay. It should work. And what are the values for alpha and u? Alpha is equal to, there is a method of estimation, 1.283 divided by the standard deviation. U is equal to mu, the average, minus 0.45 sigma. Okay, good. So if I want to perform my task, I have first to compute alpha and u. So I have to compute for my numbers over the screen the average and the standard deviation. And then I compute alpha and u. And then I use just this equation, where here p is 0.99, which means probability of not exceedance of 99%, which means probability of exceedance of 1%. Okay, let's do that. And in order to write the code, just let me go again over here. And here, the argument of the function is called gamble. And the argument of the function is the vector of the data. I can call the vector of the data like something like A, and the probability of not exceedance B. Okay? Okay, let me write the function alpha. Let me compute the standard deviation. So alpha is equal to 1.283 divided by standard deviation of A. U is equal to mean A minus 0.45 times SDA. Okay. Should work. Now, I just have to write x equal u minus log I would say that, log of minus log, good, of p. So I have to close one parenthesis and a second parenthesis. And this is to be divided by alpha. So I'm not really sure. Let me just do this, another parenthesis, because in order to make sure. Should work. This could be my code. Let me just check. Alpha mean A, okay. U minus log B divided. Okay, let's try. If there are some errors, R will tell me. I save it, okay. And then I go to R. Let me clear the console. And let's source it. No errors for now, okay. So what is the name of my vector? MyOps. Okay, let's try. Gamble. MyOps. 0.99. Okay, before I type enter, now two things may happen. Either there is an error and the R says, sorry, there is something wrong here. Fine. And then I am alerted. Or it gives to me a result. What if it gives to me a result? You shouldn't say as an engineer just, okay, that's fine. This is the result. You should gain a kind of second check on your results. Is it reliable? How can you judge if it is reliable? Remember the observation. The observation were varying from 1 to something like 29. So if you get an estimate of, with probability of not exceedance of 0.99, if you get an estimate that is less than 1, it's not reliable. If you get an estimate that is between 1 and 10, it's not reliable. If you get an estimate that is around 30, yeah, okay, between 25 and 35, it's okay. Okay, if you get an estimate of 1,000, it's not reliable. Let's see what happens. Why? I didn't write return. Okay, return next. So if I don't write return, nothing comes back. Okay. At least I know that there are no errors. So gamble 37, good. Good. You see an example of a code. You could have done the same thing in Excel. In Excel, it would take more time. And here, the difference is that you can repeat it like 0.9, 29. Look at the vector. Look at the vector. The vector, how many numbers are? Length, my ops. Okay. And do you think it is reasonable that with the probability of not exceedance of 90% over 10 numbers like these, I get an estimate of 21? Is it reasonable? Think of it. You have 10 numbers. Let's put them, sort them in ascending order. Sort my ops. You see? With the probability of not exceedance of 90% of these 10 numbers, which number would you pick as your first guess? I would pick the last but one, or not. 90% is the 90th percentile. So it's the 9 number over 10. So look at the estimate from the Gamma distribution. 21.65 is precisely the last but one. Not precisely, but very close. So it is reasonable, it is reliable. So try to get trained to make these checks automatically. Every time that you make a kind of important computation in civil engineering, you have to gain an expectation of the result. And then you see that your code, your result, matches your expectation. Perfect. You are safe. Okay? And this helps you to avoid trivial or what are called trivial errors, let me say that. And I don't forget the name in English. It's okay. But in any case, you may make some mistakes that sometimes happen that completely give you a false result for an order of magnitude. And by making this check, you get, in a way, trained to avoid these, okay? I think that that's it for now. I just want to show you a couple of illustrations, because now that we know how to work in R, how to generate data in R, we can, play with it in order to gain also visual understanding of the situation. So I already said that if I plot the density of R norm 10,000, I get a visual demonstration of the shape of the density of the Gaussian distribution, okay? Let me just make it even clearer. Now it's okay, and I can make it many times. You see there is some variability, but... And then you can see the effect of the standard deviation, because if I put a standard 0, 10, the shape changes completely. I change the standard deviation, it changes completely. Now, let's try with other distribution. RL norm. What is RL norm? It's log normal distribution. You see, and let's look at the tail. And the tail is very extended because let's type also the points. Type equal B. You see the length of the tail of the normal distribution. Because now I plotted both the points over the density. In the plot instruction, if I give type equal both, it plots both the line and the points. Okay. And if you want to see the options of plot, you just have to call the help plot, and you get everything here. Okay, now the browser, be patient, the browser is oh my God. Okay, and here there is the help. And the help is much longer, but it's, I think, okay, this one. And plot is somewhere here, just 1 second, Control F, plot is here, okay, finally. This is the help for the plot function, and it gives to you, you see here, B for both, L for lines, P for points, C for the lines part alone of both, O for both overplotted, H for histogram, S for stair steps, etc. Okay. Good. 1 second. Here we are. And this is the log normal. And of course, if you play with the parameters, because this is a log normal with mean, I don't remember, mean 1, I think, and then the standard deviation is fixed. And then you can use other distributions. Of course, in R, you don't have all the distributions. The normal and the log normal, they are there. But there are, if you want the variable, is not directly into R. You have to upload it from somewhere. We don't get into more details. Another interesting thing is the uniform. Sorry. The uniform distribution. Look at the density, is uniform. Okay. And it is not really flat also because for sampling variability, and it is also smoothed, and because the density in R is smoothed, but it gives you an idea. Okay, good. Now, okay, we have this one here. Where is the code? Here. Now, what about Python? Do you know Python? Do you code in Python? Yes, no, and you? No? Okay. So, Python is very similar to R, is gaining traction. Recently, it gained a lot of traction. What do I mean with traction? The good thing of these open source softwares is that if there is a large community behind, when they prepare codes like the one that I prepared here, they put it over the web in order to share with other users. This is a very good thing. And also, there are several packages that you can upload. So gaining traction means that a software is used by an increasing number of people. And in particular, in the context of the climate, but also civil engineering, R gained a lot of traction with respect to MATLAB in the past, and still is widely used. Python emerged a bit later, but now is gaining a lot of traction. And therefore, the result is that if you go, for instance, to a website like this one, which we will discuss soon, the Copernicus is the European Service for Weather and Climate Forecasting, the Climate and Weather Services. Copernicus Data Store. The Climate Data Store, Copernicus. Okay, here, sorry, accept all. Here you can download a lot of data. You have to register. Registration is for free. And let me see, I think I am registered. Log in. Because if you don't log in, okay, I am in. And here there are the data sets. If you click here. A lot of these, really, these are pressure levels, for instance, from 1940 to present, ERA 5, daily statistics, which means, look here, a lot of land variables over several decades, and here is many others, okay, CIs, hourly time series from 1950 to present. This is really amazing. They made available this hourly data of several meteorological variables and land variables in general. So let's suppose I want to download it. So let's see, click on the first one here. Okay, reanalysis, comparing, okay, let's see. Okay, here there is an overview, download. Okay, and here you have to select like geopotential, or let's see if there is something like U component of wind. This is something that may, and 1940, and then all month, select all, day, select all, pressure level, no, at least one selection. Okay, let's see this one, and daily statistics. Okay, frequency, 1 hourly, no, 6 hourly, because otherwise are too many. Geographical area, sub-region extraction, okay. This is particularly nice because it gives to you the option to extract the data and, okay, to extract the data by this selection. So let's take this suggestion, terms of use, accept terms, and then there is the API request, so show API request code. This is a code for downloading the data. You can submit it here, and if you submit it, it's automatically submitted. Actually, for making this selection of data, you don't have to know Python. This is a code in Python. Okay, you don't have to know it, but actually, because it is prepared for you and it is submitted for you. But actually, if you want to make more specific things, like for instance, I don't want 6 hours, but 12 hours, okay, I cannot change it here, but you have to copy it, edit it, and then submit directly through a window that let me see if I can see it here, but we will discuss this later. So basically, knowing Python, this website uses Python to make this data selection. And it's not just a coincidence. The fact is that Python is known by a lot of people and doesn't need a platform, a real, I mean, a specific platform behind it. It's not like R, not like MATLAB, and therefore is gaining a lot of traction. Okay, so my conclusion is that if you really want to download this data with a lot of flexibility, you have to learn Python. And this is what also my students told me. Look, nowadays, R is not enough. R is fine, but you have also to learn Python. Okay. So last year, 1 year ago, or 2 years ago actually, or 1 year ago, I don't remember, I had to write a paper and they wanted the code of which I used to make my assessment. Now it's an increasing request by publishers. They say, okay, fine, we publish your paper, but we want the data and we want the code because we have to make sure that people can reproduce your results. This is a way of checking the quality of the research. Fine, fair enough. So my code was in R. And they said, do you have also a Python version? Because, you know, R is fine, but still, if you have a Python version. And then I said, okay, definitely I have to learn it. And the first thing that I did was to get my code. Let's suppose that my code was this one. Actually, it was much longer, but it doesn't matter. It doesn't make a big difference. It's just a difference in terms of length. But the complication is, this is already quite a complicated code, okay? And then I said, okay, let's try to translate it. How can I translate it? And I tried with ChatGPT. Once again, ChatGPT is an opportunity. You have to, ChatGPT or whatever, Grok 3 or Gemini, and you have to learn to use it. The only thing is that you have to be aware that by definition it is wrong, because it makes a mix of several. Okay, so let's try ChatGPT. And Okay, so here we are. Okay. Can you translate the following code? And then let's go here and let's make a cut and paste, okay? Copy. And then I paste here, paste. Let's try. Sure. Okay. Okay, let's try. Let's have a look. There is an instruction which, in principle, I don't understand. Okay, import numpy as np. Okay, def gamble ap. Maybe that to define the function in Python they use this kind of def gamble ap, and then alpha is equal to 1.283 divided by npstd. There must be some way of computing the standard deviation. And np mean, some way of computing the average, and np log, some way of computing the log. Okay, fine. And if I want to try it, what if? Okay, let me install in, let me look under Windows. How I can run a Python code. So let's see if there is something here. Python 3. Let's try. I don't think. Sorry?
You can use Jupyter. It's under the web.
Yeah, okay, but I would like to install it, sorry. Okay, let's download it then. Here I just took the first link, okay. So downloads, all release Python, oh, okay, download for Windows, fine, fine. Let's see. It's not very heavy, it's 28 megabyte, it's easy. Okay, and let's install it. Install. Install now. Okay, good. Okay, let's wait a little bit. Close. Now let me search under the programs, and I think there must be something. Okay, I think it is this one, app. Okay, let's try to open it, okay? Oh, good, I got a console. This is what I was expecting, indeed. Okay, and let me see if I can, yeah, magnify it. So why don't we try to cut and paste our code here and see what happens? So, here it is, not this one, but ChatGPT, okay? So let me just copy it. Copy, and then let me go here. Oh, good. Just click it on the right and let me see def Python input line 1 module import line. Ah, okay. There is, we need to install also the libraries, and at this stage I have to clarify one thing to you. Let's look at the code. Okay. Import numpy as np. What is this? This is a library. So in Python, you have a minimal installation that comes with executable file, the installation file. But then, anytime you run it, you have to tell Python what libraries you would like to upload. What is library? Is a set of functions like those that I add into R. So in particular, there is a library called NumPy that provides a set of basic functions, statistical functions. And here, indeed, the code tells me to import NumPy. Has NP, what does it mean? It's an alias. It's an alias, okay? And I think it's not an earthquake. Okay, it's just a plane. Okay, so NumPy as NP. Indeed, you see here NP mean, NP standard deviation. These are the function of the library. I could have also uploaded NumPy as NumPy or NumPy as Alberto, and this means that to compute the mean, I should have used alberto.mean, okay? So I need the library, and keep in mind one thing. In Python, there are a lot of libraries. This is why they are not uploaded by default. You have just to upload what you need. If I want to compute the mean and the standard deviation, there are several libraries. You can use NumPy, which is a classic library for for computing statistics, but you can use others. And this makes it a bit complicated because if you ask ChatGPT to translate another time, it could give you another library. And this is what happened to me. So I didn't understand at the beginning, but what is the difference here? The difference is very subtle. And ChatGPT, of course, it makes the selection based on what by chance it encounters. But the difference is in some of the cases, very minimal, and it depends on needs that you may not need, actually. And therefore, NumPy is a very classic one. So I suggest that we stick on NumPy, but NumPy has to be uploaded into Windows. How to do that? I remember that it's very simple, but I don't remember how to do. So let's try. Install NumPy Windows. Okay, install NumPy Windows 11. NumPy installing NumPy. So let's see. The only prerequisite is Python. Very good. And let's make it here. Is Python. If you don't have Python, okay, no, we have Python. Okay, so it seems that a modern Python package manager, okay, uvpip import, verify the installation. Okay, let's try with this command, uvpip install NumPy, and let's try. I don't understand if I have to run it under Python or under the console of Windows. Let's try to make it here. Here it doesn't work, so let's see. Another verified installation, troubleshoot. Fix environment pipconda. Okay, let's see if using conda or beyond different method. Click environment based. Pip and conda, they function. So just 1 second that I read. So let's try to forget UV, no? Okay, I think I have to go to let's try, I think Python. Let's try to do this. Let's try to open a terminal under Windows, terminal. Okay, and let's see, pip. Okay, I think this probably works. Pip install numpy. Okay. Give me 1 second more. Okay, here it is, 1 second. The simplest way to pip Python pip okay. Ah, yeah, pip. Okay, let me just try this. Okay. And let's try to do it in the no. Okay, so let's see, verifying installation. Okay, Python 3. Get a second. And then if I can't resolve it, we can drop it just a second. So you may need to run the command prompt at the administrator. Yeah, I'm not sure I can do that here. Let's see. Because Apple, okay, just one second, Windows 11. Let's try with this one. Yeah.
What is written, I see you, because Jupyter include all of the libraries.
Okay, okay.
It needs you include the library.
Okay. Jupyter is...
First of all, you should download the Anaconda Navigator.
okay, yeah, I understand.
Include all of the, you want to see it?
Yeah, I understand, but still it's a bit long for doing it now. Anaconda, yeah, I know how to use it. And
I write, now I write download and continue.
okay, and it runs. It runs. And the result is the same that you got into R for a given probability?
Maybe.
Maybe, okay, that's fine. Okay, let me go back to the code then, because this is the code that we try to upload, and of course, what I am missing to run it is the library, and we will discuss how to, what is the best way, because Anaconda, I mean, I prefer to not introduce Anaconda at this stage, maybe later, but I'm not really sure. And I'll tell you next time a very smart way of importing it. What I wanted to highlight here is that you got this code, and my aim was to run it and to compare the result for a given probability with R. It should be more or less the same, and with more or less I mean that the difference, if any, should be at the third, fourth digit, because basically the statistics that are computed are the same. The only difference may be in the numerical approximation, but it shouldn't be a huge difference. And what I want to point out is that you see the structure is very similar, and of course there are different names of the functions, and the function is uploaded in this way, and then you can run it in Python for any value of A and P. Of course, I also need to upload the vector A into the same vector A into Python. But the structure is very similar. And so how it is structured, a Python program? My suggestion for you, let's look for a tutorial, a basic tutorial over the web. And my suggestion is this tutorial. Just 1 second. Python. Okay, probably I closed it, so let me open another browser. Python tutorial. And what my suggestion is to take this one. There are many, and it really, they are equivalent, but I prefer those that are managed by the, okay, let me see this one. Let me see another one, because learn Python tutorial. Python 3. Okay, this one. Very good. This is my suggestion. This is under python.org, and you see that the alert here. This tutorial is designed for programmers that are new to the Python language, not beginners who are new to programming. I think you are classified as a programmer that is new or almost new to the Python language. So I think this is the right reference for you. And here there is the table of content. Here, using the Python interpreter, it tells you to do what we already done, to get to the console here. And here, there are some basics starting from the beginning. So we can cut and paste this instruction. So let me copy it, and let me go to the. So what is this instruction? Is defining a logical variable. The world is flat, true, and I think you see it can be recovered. And then here there is something that we didn't discuss in the morning, a condition. If the world is flat, what does this mean? Let me copy it. It means, this is a condition, if the world is flat, so implicitly, if the world is flat is true, then print, be careful not to fall off. Okay? If the world is flat is false, okay, arrow up, nothing is printed out. Okay? And my suggestion for you, if you are interested in Python, this is very easy. If you go through this, there are also the instructions on using Python as a calculator. Okay, so 2 plus 2, like we did in R. And here there are other examples, and then there will be also the page on uploading the libraries, okay, which you find later on. So this is, I think, an excellent guidance for, and now I will put also the link on my website. It's an excellent guidance for you to get instructed, as we did for R. And I'm not going into more details now. We will use Python later on to download some data from the Copernicus Climate Data Store. I mean, this is something that, again, like for R, if you're interested, this is a good start. Okay, I think we can close here for today. And for the lab, I just wanted to tell you one thing. I cannot make the lecture on October 30, which would be my last one, because next week is teaching Ray Guo, who is the other teacher. And then I think he was supposed to teach on the 23rd, and then I was supposed to teach on October 30. I have to change the calendar because I cannot teach that day. I will tell you when is the next lecture, okay? But for sure next week you have the lecture with Ray, okay? He's a guy originally from China. As I said, he's excellent, and I'm sure that you will enjoy. Okay, good. No, in person, yes. Yes. Okay. Good.